Solving quadratic equations using completing the square method. How do we solve quadratic equations using completing the square method? Now let us consider the question given here. So the question says, solve the following quadratic equation using completing the square method. Using completing the square method. So the question is, or the equation is 2x squared plus 3x minus 5 is equal to 0. How do we solve this quadratic equation using completing the square method? So we have 2x squared plus 3x minus 5 is equal to 0. We have to solve. Now, to solve a quadratic equation using completing the square method, we complete square for two terms, for just two terms. For just two terms, the two terms that have the variable. So this minus 5, we can transfer the minus 5 to the other side. So doing that, we're going to have 2x squared plus 3x is equal to 5. This is minus 5. When you transfer a number from one side to the other, the sign changes. So that's why we're having 5 here, plus 5 here. Now, we complete the square for two terms, not three. Two terms that have the variable. The another condition again is to complete the square for given a term or expression, the coefficient of x squared must be 1. To complete the square for any given expression, the coefficient of x squared must be 1 before we can complete the square. So from here we divide all through by 2. So doing that, we're going to have x squared plus 3 all over 2x is equal to 5 all over 2. That is dividing all through by 2, so that the coefficient of x squared will be 1. So now we complete the square for the for what we have on the left hand side. How do we go about that? We have x, right, x plus half of the coefficient here. Half of 3 over 2 is 3 all over 4. Half of 3 over 2 is 3 over 4. That is 3 all over 2 divided by 2. The same thing as 3 all over 2 multiplied by 1 all over 2, and that will give us 3 all over 4. So this is how we got our 3 over 4 here. So x plus half of the coefficient here, so that will be 3 over 4. Now all squared. Then introduce minus, then square of the number here. Square of that, and that will give us a 3 all over 4 squared. Then on the right hand side, we still have our 5 all over 2. So that means we have completed the square for this. X squared plus 3 over 2x. Completing the square for that will give us what we have on the left hand side there. Now tidying up this, so we're going to have x plus 3 all over 4 all squared minus 9 all over 16 equal to 5 all over 2. So from here we have x plus 3 all over 4 all squared is equal to 5 all over 2 plus 9 all over 16. So this is minus 16 over 9. We transfer it to the other side, it becomes plus 16 all over 9. So from here we can write x plus 3 all over 4 all squared will be equal to the LCM of 2 and 16. The denominator is 2 and 16. The LCM is 16. 2 into 16, 8. 8 times 5, 40. plus 16 into 16, 1 times 9, 9. So from here we can rewrite x plus 3 all over 4 all squared will be equal to 49 all over 16. So from here we're going to have x plus 3 all over 4 will be equal to square root of 49 all over 16. And when you square both sides, so that these two here will disappear. So we're going to have this. So from here, we have x plus 3 all over 4 is equal to plus or minus 7 all over 4. Square root of 49, 7, square root of 16, 4, plus or minus. We must introduce that. So from here, therefore, x will be equal to minus 3 all over 4 plus or minus 7 all over 4. This plus 3 over 4, when we transfer it to the other side, it becomes minus 3 over 4. So this is therefore. So from here, we have x being equal to minus 3 over 4 plus 7 all over 4 or minus 3 all over 4 minus 7 all over 4. So from here, so we're going to have minus 3 plus 7 or minus 3 minus 7. So eventually, so we're going to have minus 3 plus 7, so that is 4 all over 4, or minus 3 minus 7, that is a minus 10 over 4. So from here, therefore, our x will be equal to 1 or minus 5 all over 2. So this is how we solve quadratic equation using what? Completing the square method.